Hi everyone, welcome back to my channel. Today we're going to look into problem solving using Pythagoras. I kind of put all different type of problem solving questions into a few categories. Those are the most typical ones that we use and normally we get asked. So before we start on all that, let's quickly revise on how to using Pythagoras to find a missing side. If you're confident of this, you can pause this video, give it a go first, and then check the answer yourself. For those who want to go together, or I assume that you are done. So remember what we do is normally find the right angle first, and then I'm going to mean here. Find the right angle first, and then do an arrow across. So if that is a number, we're minusing. If that is a letter, we're plussing. So in this case, it's a letter. So the unknown sign is a letter. So the unknown sign is opposite of the right angle, we're plussing. So x squared is square root of 9 squared plus 12 squared. Okay. Calculator. Oh, that should be 15. Okay. Again, similarly. Now this one's known. That means we minusing. So a squared equals, that's x. A equals square root of 17 squared minus a squared. I'll kind of skip the a square thing because actually don't really need it here. You can just put square root and everything in there, make it a lot quicker. Just do one step. Where is the calculator? There. So square root of 17 squared minus a squared is 15. Again, don't forget unit. Now next one, that is a letter we're plussing, so p equals to square root of 9.6 squared plus 12.8 squared. Doesn't matter which one first because they're both small sides. That is 16 centimeter. Letter again plus 7.5 meter. That's a number, so I'm minusing. Obviously use the biggest one minus the smallest one, okay? That, it's not given, but they should indicate that it's a right angle triangle. Opposite, there's plussing. That's a 6. Okay, same with this one. That is a number, so we're minusing. So t equals square root of 50 squared minus 48 squared. meter. Okay, if you're alright with this, then you are ready to do problem solving. So let's start with the problem solving question with shapes. So normally shapes that we actually need to know what they are and what how special they are. If you don't remember, go back to the shapes chapter and revise on those shapes. So here is a rhombus. Rhombus, well, let me see if I can draw rhombus here. Not really. Oh well. Yep, kind of can. So you probably think, oh, there's a diamond. Well, there's something special about the about rhombus is that all the sides are the same. So remember, we use this to indicate all the sides are the same, and then the diagonals are perpendicular to each other, and the diagonal bisect each other. So that means this one and this one is the same, this one and this one is the same. Okay, so we have a rhombus here. It says the length of the diagonals are 4 centimeters and 6 centimeters. So that means I'm going to use a different color. So that length here to here, this is shorter one there, so it starts with 4 centimeters. And then the length here to here, that is 6 centimeters. Okay, so the easier question will give you a diagram, but the harder ones actually need to ask you to draw. So you actually know your shapes, otherwise it could be quite difficult. Now, you're asking us to find the length of each sides. Well, all the lengths are the same. Luckily, we only need to do one. And the thing is, to do this, you need to find right angle first, a right angle triangle first, because using Pythagoras, the only advantage we have is you need to be a right angle triangle. So for a shape question, try to find a right angle triangle first that contain all the information, contain two sides that we know and one side that we don't know. So in this case, the shape, you can pick any of the triangles, but they really basically the same. So this triangle here is right angle triangle, and we know two other sides. How do we know two other sides? Well, let's have a look at this. So the total diagonal is 4, and then it cut into two halves. So each of the half is 2 centimeters. So that means it's 2 centimeters here. So similarly for the other one, so the total length is 6, and then it cut in half. So either side, each of the side is 3 centimeters. Okay, so we have a right angle triangle here. We're looking for this. Let's call this x. Okay. Right, so we have a right angle triangle here. We have two sides that we know. We have one side we don't. So we can use Pythagoras. Okay, so this is right angle triangle. This is 2 centimeters, 3 centimeters, x. You not necessarily need to draw the diagram, but I'll recommend it because that's kind of showing your thought process. Okay, so again, this one's unknown, so we're plussing. So x equals to square root of 2 squared plus 3 squared. So, 2 squared plus 3 squared. So 4 plus 9 square root of 13. So sometimes they ask you to write as absolute value. You just need to keep it as square root of 13. We're going to do surf in year 9. So cert in year 9. So don't worry about too much about that. But just if they ask you to find absolute value, that is your absolute value. If they ask you to round it, that will be 3.6. Depends on how many decimal places. If they ask you to do 2, that will be 3.61 centimeters. Okay, that's it. Now I'm going to give you one more example because that may not be the best one. Two examples. Anyway, so those are a little bit more complicated, but the principle is exactly the same. Now you need to know your shapes. Parameter questions are kind of like a typical Pythagoras question because they examines you how well you know the shapes and how well you can dissect them. So let's have a look. Well, most of the times you're going to see triangles and rectangles, so just keep that in mind. For rectangles, opposite sides are the same, yeah. So the opposite sides are the same. So 45 on the bottom, so 45 on top. Because we need to find parameters, so we need to find total length, so we need to find every single side on the outside. Okay. Now, this is 28. This is 32. If you add them together, that will be 60. So the left hand side 60, right hand side also 60. So this is 60 centimeters. Well, we got those ones. We still have two we don't know. let's say this one's A, this one's B. But do you have all the information to work it out? Yes. Okay, so let's try to draw this triangle first. I'm going to do the right one. This triangle here. Okay, so I'm going to move that out. Copy. Okay. Make it a little bit bigger. Right, so we got information on it. We know that this side here is 28 and this side here is 16. We want to look for A, that's right angle, so there's a plus. So A equals to square root of 28 squared plus 16 squared. So 28 squared plus 16 squared. We got about 32.25. It didn't ask, so but by default I normally run to 2 decimal place. Okay, so centimeters. Yep. So now we got B. So going to do a blue one. B is in this triangle here. Okay, I'm going to copy this and bring it out here. Oopsie, too big. Anyway, again, we know the shapes. This is 32 centimeters and the top is 16. Sorry, too cramped. And then this is B. So when you look for B, it's exactly the same. B is unknown, so we're plussing. So 16 squared plus 32 squared. So that will be 35.78 centimeters. Now, we have every single size on the outside known, so the parameter, just add them all together. So 32.25, take that, plus 35.78, take that, plus 45, you can double it, but I'm just going to add it. And then these two are done, and then 60. So just add them together. So 32.25 plus 45.78 plus 45 plus 45 plus 60. So the parameter is 218.03 centimeters. As you can see, I tick through them, so I know that I don't miss anything. Okay. I hope that's easy for you. You can pause this video and try to do that next one yourself, or you can just watch. Okay. I recommend do it first. Right. Now, I assume you're done. So this is a rectangle. So opposite sides are the same. So all you need to do is find one, and then we know the other. The thing being here is that we can actually, let's label this is A, and this is B, and then see whether we can draw right angle triangles. Well, apparently we have 3. We have quite a different way to do it, but I'm just going to use the 2 smaller ones. Sometimes small ones probably the better way to go. So it's going to be a red one, so copy. Let's see the red one here. Now it's a right angle triangle because they indicate right here, and then you got 39 here, and then bottom is 72. So we got B here, unknown, so opposite, so I mean plussing. So now B equals square root of 72 squared plus 39 squared. So it's 81.88. So A is quite similar. I'm going to do pink. So pink is here. Copy. Oopsie, it doesn't have enough space. I'm going to move it over here. Okay. Apologize, there's some more space here. So this is 39 centimeters. This is 54 centimeters. Well, one side right angle, the other side should be right angle too, yeah, because, you know, perpendicular means both sides of the triangle. Now A is here. You can use the other one. So you can use the bottom triangle, the big triangle as well, but I'm just going to use a smaller one. Okay, so A is unknown, so the opposite of triangle is unknown. So A equals to square root of 39 squared plus 54 squared. Okay, so 39 squared plus 54 squared. So it will be 66.61 centimeters. So, actually we have all of them known because the opposites are the same. So the perimeter, the total on the outside, is, you got 2 A's and 2 B's because the opposite is the same. So I'm just going to double it here. So 81.8A times 2 plus 66.61 times 2. So 81.8A times 2 plus 66.61 times 2. That would be 296.98 centimeters. Okay, don't forget your unit. So too easy. We'll take for that. Don't forget. Okay, cool. Now, pause this video, give it a go on those questions first. They actually are easier than the one I show you. Yeah. Well, I'll give you a hint on those ones first. You need right angle triangle for the unknown, so find the perimeter. I forgot to write the question down. Okay. Now you should be able to do that. Okay, we done? Cool. Opposites should be the same, so this is 38. Now, the top is 53, so this is 53 here. So 70 minus 53 is 17 on this triangle here. Our goal is to find this length, so we can add them all together. So to find that should be plussing. So x is 38 square plus 17 square. That should be 41.63. Okay, so perimeter is 38 plus 53 plus 41.63 plus 70 is 202.63 centimeters. Easy. Now similarly, this one opposite is the same, so this is 14, 18 here, 30 minus 18, this is 12. Okay, so we got triangle here as 14 and 12, so we're looking for x. X equals 2. Opposite the opposite here is unknown, so we're passing. So 14 square plus 12 square, that should be 18.44. So to add the parameter and them all together, so 18.44 plus 18 plus 14 plus 30, so it'd be 80.44 centimeters. Okay, similarly this one 13, and then 8 here, 70 minus 80, this is 9. So a lot of cases that the diagrams are not to scale, so if the number is weird, don't worry, it should be alright. We normally don't put that to scale, so yeah. Right, for this triangle here, this is x, so opposite also plussing. 9 square plus 13 square, so that would be 15.81 centimeters. So perimeter would be 15.81 plus 8 plus 13 plus 17. So 53.81. Okay, give yourself a tick if you got it right. Now next one, well, this one is complicated because we actually have two that is unknown. You need A and B. So let's do A first. Now A is this side. Well, obviously it's unknown, so we need to plus it. So A is square root 25 square plus 50 square. So that will be 55.90. B, similarly, 25 square plus 30 square. So that will be 39.05. You just need to add all three together. Don't forget unit. So parameter is A, 55.50.9, sorry, plus 39.05 plus well, we need to add the bottom two together as well. Okay, so this plus 80. That's the bottom bit. That will be 174.95 centimeters. Okay. Similarly, this one, find this first. So A and B. A is square root of 36 square plus 33 square. So that is 48.84. B is square root of 67 square plus 33 square. .69. So parameter, just add them all together. 48.84 plus 74.69 plus 36 plus 67. So we got this, and this, because they are total length. So 226.53 centimeters. Okay. Well, a little bit repetitive here. That's okay. They're both the same anyway. So this one and this one. So A is I'm just doing calculate square root of 31 square plus 27 square. So that would be 41.11. B is 31 square plus 19 square. Yep, so that would be 36.36. Okay, parameter, just add them all together. 41.11 plus 36.36 plus 27 plus 19. You're probably wondering why don't I add the middle one? Well, that's inside, so you don't add inside and you add the outside. Okay, that's parameter. So it's 123.47 centimeters. Okay, too easy. Now, let's move on to something a little more complicated that they describe you the situation. So for example, here two poles are that. So first thing first, you always draw a diagram. So two poles. So you got the ground and level ground. So you got level ground. You got one post here at 7.2 meters high, and the other one's 9.6 meters high, and then they're 11 meters apart, so 11 meters apart. Calculate the length of string required to stretch from the top of one pole to the other. So we're talking about the length here. Let's use X to represent it. Oh well, it's really similar to what we just did earlier, isn't it? So to do that, I'm going to put in some information. So I'm going to draw this here because we just make a rectangle and also make a right angle triangle. Okay, so you have 7.2 on that side, that will be 7.2 on this side too. So that means the top is 9.6 minus 7.2. So how much taller? The 9.6 is over the 7.2. So 9.6 minus 7.2. So you got 2.4 meters here. And then the red one opposite is the same because it's a rectangle. So that will be 11 meters as well. So we just need this right angle triangle here to kind of solve this, isn't it? So to do that, let's draw that triangle out. And we got all the information we need. That's a right angle triangle. That's 2.4 meters. That's 11 meters. And we want x. So, similar to what we did earlier. Square root of 2.4 square plus 11 square. 2.4 square plus 11 square. That would be 11.26 meters. That's it. So that's our solution. Okay. Didn't ask it to round it, but yeah. Too easy. Cool. Moving on. So some of the questions, they give you a diagram. So to work out the total. Now you can pause this video and give it a go first, and then we go through it together. Okay. Now, you done? Cool. So first question here. Well, we're looking for the height of the kite. Well, because the Oliver is holding it in his hand, which is 1.2 centimeters. Whoa, you mean 1.2 meters? Sorry, there's something wrong with the diagram. 1.2 meters high. Oliver's not that short. Anyway, so we can leave that out first. We do the triangle on top because we want to find. Let's find this A first, because the height is basically just A plus Oliver's height. So let's do that triangle here. Again, always look for right angle triangle first. So we got A here. This is 18 meters. And the string is 30 meters. Well, so A, that is a number, so we minus. So square root of 30 square minus 18 square. So 30 square minus 18 square. 24 meters. Alright, so A is 24 meters. So the height would be A plus 1.2. So the height is 24 plus 1.2, which is 25.2 meters. So that's how high the kite is. So that's the answer. Okay. Cool. Now, second one, a kite fly with 48 meters strings, and at the time it's this level on the top. So we know how high the kite is. Looking for the horizontal. So, well, this one's even easier because you just have, I'm going to do it here, not enough space on the right hand side. So you have it here. You know that this is right angle triangle because buildings are perpendicular. So 23 meters, that is 48 meters. Looking for x, so again, that's known, so that is minus. So x is square root of 48 square minus 23 square. Again, you have to use the long one minus the small one because you can't have negative inside square root. Otherwise, you got error on your calculators. Okay, so in this case, so horizontal distance is 42.13 meters. Too easy. Now measure the area of ground concrete circular diagram to the full rectangle. Measure the diagonal that is the area. Measure a rectangle. Explain your answer. Okay, well this one is a little bit tricky, isn't it? Because we have the three sides, but we are asking whether it's a rectangle. Well, how do we define a rectangle? Yes, that's right. So the right angles is for rectangle there is right angle in every single corner. So all you need to do is prove that it's right angle triangle. Oh, whoopsie. Remember how we find a right angle triangle? We can use Pythagorean chain. So if these two square add together equals to this square, that means it's a right angle triangle here. Okay, so we don't know, so let's test it out. So let's add the smallest two one first. So remember we circled the two smaller one. So 4.2 square plus 3.8 square. Add them together first. 4.2 and 3.8. Make sure the number is right. Plus 3.8 square. So that would be 32.08. Okay. Now let's try 5.2 squared. Let's see what it is. Is 27.03. So these two numbers are not equal. So 4.2 squared plus 3.8 squared is not equals to, equal with a slash means they're not equals to 5.2 squared. Therefore, is not a right angled triangle. Oopsie. Therefore, is not a rectangle. Too easy. Okay. Now the hardest one is 3D problems. You kind of need to visualize it, but I'll try to give you guys as much hint as possible. So I got two examples here. Even can do 3D, you're doing really well in Pythagoras. Okay. So no, always draw a right angle triangle with the missing sign in there first. So in this case, we're looking for this one here. So it's from one side of the to the other. To draw a triangle, right angle triangle, if you cut that shape, that prism from the top, and then you will see that if you connect this, and then this, that will be a right angle triangle. If you look from this side, you should see something like, you should see this. Oopsie, let me do it again. Right, and this, I'm going to highlight that. That blue part here should be this length. Okay, and it's kind of given because that and that is the same, so that is 5 centimeters. Okay, we don't know what this is. This is X, and then on the bottom here, we cut is kind of let me do what color? Purple. So this one here is actually a little hard to find, hey. But if you look from the top, so look from the top here, you should see these two. The top. Okay. Let's call this A. So this should be A if you look from the top. And then oh well, this is complicated. So from this corner to this corner, well, this is not blue. Let's not use blue. So this black one here, from this corner to this corner, that one is black. So that should be this one too. It's a little bit hard. You kind of need to rotate, use your head to rotate the shape and see that. So that should be the same as the top one here, because it's a rectangle on the side. So this should be 15. Okay, now this one here, I'm running out of color. I'm going to use green. This one here should be the same as this one here. Oopsie. Right, so that means is 12. Okay. And A here is that A here. Okay, so what we need is oopsie. What we need is we need to find what A is first on this triangle. Right angle triangle. It's a little bit hard to see in 3D that is right angle triangle, but it's a right angle triangle because the right angle is right here, because the bottom is a rectangle. And then using A, we should be able to find X. Okay, so try to picture that shape in your head and see whether you can rotate it and see different side, because that's probably the hardest part in 3D shapes. Okay, I put it in here as an extension, so we're going to do a little bit more on that in year 9, but that's probably the hardest question you're going to see. So if you want a little bit more challenging question like this, do the extension booklet. Okay, so all right, let's start on that one. So we this one you have 2 letters. We can't really find 2 letters using one triangle, so we need to start with the one that we only have one letters. So the bottom one here, we got A is the opposite, so we know the other two, so we just add them. So 15 square plus 12 square. So 15 square plus 12 square should be 19.21. So that is 19.21 here. Okay, so well, now we know how to find x because we have two numbers x. No, x here equals to square root of 19.21 because x is unknown, the other two is unknown, so add them. 5 square equals to 19.21 square plus 5 square. That is 19.85 centimeters. So we work out what x is. Okay. If you okay with this now, have a go on the second one. Second one is actually a lot easier. Okay. So basically, we're looking for y. If you cut the this rectangle along this way, you should see a rectangle on the side, and then if you cut it this shape here, sorry, you should see, and you're looking from this side, you should see a rectangle. Okay, and then you got the diagonal here, which is y here. So this is y centimeters, and then this is 5 centimeters. The bottom we actually don't know, so we need to look at we need to work that out. So I use this is a. Okay, but if you look from the top, the rectangle from the top here, you should see. Oopsie, I'm going to use different color. You're going to see a rectangle like this. Okay, and this is A. So this should be A. Yeah, sorry, should be using different color. Oh, let me use different color. Let me make it black. Okay. Now, that should be. This should be 6, and then that should be 8. This is a triangle. This is a triangle. Now we find a first. So a is square root of 6 square plus a square. I know that is 10. Okay, so we work out 8. A is 10 centimeters. You can work out y is a right angle triangle here. So opposite, so that's unknown. So y equals to square root of 5 square plus 10 square. That would be 11.18 centimeters. Okay, so that's your answer here. Right, so if you get this, you're doing really well in Pythagoras. So yeah, this is the end of the video. I give you a few questions to do. So homework's in your page 58 to 60. These 3 questions, but it's just a little bit more of the wording, so and they space out into 3 pages. Okay, so the answer should be in the back of your textbook, so I'll let you to do that. So that concludes today's video. Thanks for watching. We'll see you guys next time.